first instruction here, moving a word, the value at R5 is going to go into R7. We're going to copy it over to R7. This R7 here is our counter, and we can set any register we want to that. And down here, now we're going to increment R7. And the reason that we do that is because, let's go back to the original example and say that, n is equal to 10. And so we're saying that from here down, there are 10 elements. And this is just by definition. And, we could easily also say that by definition that it doesn't include, that it does include, right? And so this whole thing would be, you wouldn't need the increment anymore because, it would include, this would go to 11, or it would be, included in here. But for the sake of this problem, it is established, apparently, that, the elements from n down are going to be the value of n. So that's why we need this increment R7, and we only do this once. This isn't in our loop, it's before the loop, so we only say that once. Continuing on, moving a word at the value at the address of R5 post increment, and then here we have our address of R6, and this, technically, there should be a 0 right there and for the offset. And I asked the TA, I said, hey, what's the difference if you have an at R6 and if you have, and you have parentheses R6? And he said, well, at the surface, nothing. If you have here, the value is 200, the value here is going to be 200 as well. The only difference is that with the parentheses version, and I'm sorry, I don't remember what it's actually called. Maybe maybe it is the offset or something like that. But this can never ever be in the source. This is always in the destination. And typically, the at symbol, the address, it is always in the source. And why the microprocessor can't handle the parentheses in the source, I do not know. And so then, coming down a line, right here, we are incrementing R6. And the reason that we're doing that is up here we have R5 is incrementing, but for some reason we can't just add like an increment here to this line. So we have to make a whole new separate line down here that does that for us. And the reason we're doing that, sorry, let me erase some of this. Okay, so the reason that we're incrementing R5 and R6 is we're basically saying in our loop, hey, take this value, R5, and put it and move it, copy it into R6, and then we're going to increment, take R5, put it into incremented R6, and so on and so on. And so that's why we have to keep incrementing them. So the way that the loop counter works, right, this is going to be, the loop is going to go all the way down to 0. So this R7, this is what this jump is saying. This jump is saying jump if not equal to 0. So jump back to your loop if not equal to 0. So this loop is going to keep running and running and running. We have it right now at n equals to 10, and it's gonna keep running and decrement every time, and it's going to go if not equal to 0, and if it is equal to 0, we have our return here, and it is a return because it is a subroutine.